Imagine a world where weather patterns are no longer predictable, where coastlines retreat and cities face rising waters, where ecosystems struggle to adapt. But what if I told you that the forces behind these changes are not some distant threat, but rather something deeply connected to our everyday lives? Welcome to the science of climate change, a subject that's both complex and critically important. In this video, we'll dive deep into the mechanisms that are driving climate change. We'll explore the intricate balance of our planet's climate system, uncover the role of greenhouse gases, and reveal how human activities are tipping the scales. But before we get into the details, let's first understand what climate change really means. What is climate change? Climate change refers to long-term shifts in temperatures and weather patterns, primarily caused by human activities, especially the burning of fossil fuels. These changes are not just a natural variation in climate, but a significant alteration that has widespread effects on the environment. Natural versus human-induced climate change. While Earth's climate has naturally fluctuated over millions of years, what we're witnessing now is unprecedented. The rapid increase in global temperatures, sea level rise, and extreme weather events point to a major influence from human activities, primarily through the emission of greenhouse gases. Climate versus weather. It's essential to distinguish between climate and weather. Weather refers to short-term atmospheric conditions, while climate represents long-term averages of weather patterns over decades or more. A hot day or a cold winter doesn't necessarily indicate climate change, but consistent long-term trends do. The greenhouse effect. Nature's blanket. One of the key concepts in understanding climate change is the greenhouse effect. This natural process is what makes Earth habitable, but when amplified by human activities, it leads to global warming. How the greenhouse effect works. The sun's energy reaches Earth in the form of sunlight. Some of this energy is absorbed by the Earth's surface, warming it, while the rest is radiated back into space as infrared heat. Greenhouse gases in the atmosphere, like carbon dioxide CO2, methane CH4, and water vapor, trap some of this heat, preventing it from escaping into space and thus warming the planet. The role of greenhouse gases. Naturally occurring greenhouse gases are essential for life on Earth, maintaining an average temperature that supports ecosystems and human activities. However, human activities have dramatically increased the concentration of these gases, particularly CO2 from burning fossil fuels, leading to an enhanced greenhouse effect. Human activities. The catalyst of change. The Industrial Revolution marked a significant turning point in the relationship between humans and the environment. The massive burning of coal, oil, and natural gas has released vast amounts of CO2 and other greenhouse gases into the atmosphere. Fossil fuels and carbon emissions. Fossil fuels are the backbone of modern society, powering everything from cars to factories. However, when burned, they release CO2, a major contributor to global warming. Deforestation further exacerbates this issue by reducing the number of trees that can absorb CO2 from the atmosphere. Agriculture and methane. Agriculture, particularly livestock farming, is a significant source of methane, a greenhouse gas that is much more potent than CO2 in trapping heat in the atmosphere. Rice paddies and landfills also contribute to methane emissions. Industrial processes and nitrous oxide. Industrial processes, such as the production of cement, fertilizers, and chemicals, release nitrous oxide N2O, another potent greenhouse gas. How do we know climate change is happening? The evidence for climate change is overwhelming and comes from a variety of sources. From rising global temperatures to shrinking ice sheets, the signs are all around us. Global temperature rise. The Earth's average surface temperature has risen by about 1.2 degrees Celsius since the late 19th century, with most of the warming occurring in the past 40 years. This may seem small, but even slight increases in global temperature can have profound impacts on the environment. Melting ice and rising sea levels. The polar ice caps and glaciers are melting at an alarming rate, contributing to rising sea levels. This not only threatens coastal communities but also affects global weather patterns. Ocean acidification. The oceans absorb about 30% of the CO2 emitted into the atmosphere, leading to ocean acidification. This has serious consequences for marine life, particularly for species like corals and shellfish that rely on calcium carbonate to build their skeletons and shells. Extreme weather events. The frequency and intensity of extreme weather events, such as hurricanes, droughts, and wildfires, are increasing, and climate change is a major factor driving this trend. The impact of climate change. Climate change is not just an environmental issue, it's a human issue that affects every aspect of our lives, from health and food security to the economy and global stability. Health risks. Rising temperatures can exacerbate health problems, such as heat stress, respiratory issues, and the spread of infectious diseases. Extreme weather events also pose direct risks to human safety. Food and water security. Changes in weather patterns affect crop yields, leading to food shortages and higher prices. Water resources are also at risk, with droughts becoming more frequent and severe in many parts of the world. Economic impacts. The economic costs of climate change are enormous, from damage to infrastructure from extreme weather events to the loss of productivity due to heat waves. Climate change also threatens entire industries, particularly those dependent on natural resources. Biodiversity loss. As temperatures rise, many species are unable to adapt quickly enough, leading to a loss of biodiversity. This not only affects ecosystems but also the services they provide, such as pollination and water purification. What can we do? While the situation is dire, it's not hopeless. There are steps we can take to mitigate climate change and adapt to its impacts. Transition to renewable energy. One of the most effective ways to reduce greenhouse gas emissions is by transitioning from fossil fuels to renewable energy sources, such as solar, wind, and hydropower. These sources are not only cleaner but also increasingly cost-competitive with traditional energy sources. Energy efficiency. Improving energy efficiency in buildings, transportation, and industry can significantly reduce emissions. This includes everything from insulating homes to developing more fuel-efficient vehicles. Carbon capture and storage. Carbon capture and storage (CCS) technologies can capture CO2 emissions from power plants and other industrial sources and store them underground, preventing them from entering the atmosphere. Reforestation and afforestation. Planting trees and restoring forests can help absorb CO2 from the atmosphere. Forests also provide other benefits, such as biodiversity conservation and water regulation. Climate policy and international cooperation. Addressing climate change requires strong policies at the local, national, and international levels. The Paris Agreement, for example, is a global effort to limit global warming to well below 2 degrees Celsius, with efforts to keep it below 1.5 degrees Celsius. The future of climate change. What lies ahead? The future of climate change depends on the actions we take today. If we continue on our current path, the consequences will be severe. But if we act now, we can still avoid the worst impacts. Climate projections. Climate models predict a range of possible future scenarios, depending on the level of emissions. If we reduce emissions significantly, we can limit global warming to manageable levels. However, if emissions continue to rise, we could see temperature increases of 4 degrees C or more by the end of the century. Adaptation and resilience. Even with aggressive mitigation efforts, some level of climate change is inevitable. We must therefore also focus on adaptation, building resilience to the changes that are already occurring and those that are yet to come. The science behind climate change is clear and compelling. The evidence is overwhelming, and the consequences of inaction are too great to ignore. But while the challenge is immense, so too is our capacity for innovation and change. By understanding the science, making informed decisions, and taking action, we can protect our planet for future generations. The time to act is now. If you found this video informative, please like, share, and subscribe to our channel for more in-depth explorations of the world around us. Together, we can make a difference.